guys, welcome to your day 6 video on proving a quadrilateral is a rectangle. If you remember yesterday, we gave you a rectangle and you used their properties to prove things. So today we're actually going to prove that something is a rectangle rather than just giving it to you. So starting right at the top here, it says, just a little reminder here, in order to prove that something is a rectangle, you need to first prove that it's a parallelogram. So keep in mind, proving something's a parallelogram would be proving both pairs of opposite sides congruent, or both pairs of opposite sides parallel, or one pair of opposite sides both congruent and parallel, and so on and so forth. So you can review how we did that a couple days ago. So the first one is, if a parallelogram has one right angle, then it has 4 right angles. So let's actually talk about that for a second. If we know that we have a parallelogram, we know both pairs of opposite sides are parallel. So if I know one of the angles is a right angle, like angle A, but then I also know that consecutive interior angles are supplementary, then that means working all the way around, all of these angles must be right angles. Okay, so just by having one right angle in a parallelogram, that actually justifies that all the angles are right angles. And as we know, that's a special property of a rectangle. So my first conclusion would be that angle B, angle C, and angle D would also be right angles, and therefore that would prove that I have a rectangle for ABCD. Now, when I actually go about proving this, so proving a parallelogram is a rectangle, what I just showed you at 1 justifies why at step 2 I can use this theorem. So this is the one we're going to use in our actual statement reason proofs, that says if a parallelogram has one right angle, then it must be a rectangle, okay? Because then all the angles would have to be right angles. The second one that we'll use is if we can prove the diagonals are congruent. So if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So in our image over here, if I know that this is a parallelogram and I can prove that AC is congruent to DB, or maybe they give it to me, then therefore I have a rectangle. Okay, so really it's theorems 2 and 3 that we have bolded are the ones that we're going to use to prove a rectangle. So there's only 2 additional theorems at this point for the lesson today. All right, so looking at our first proof here, given parallelogram PQRS, I give you that PQ is congruent to QR. Prove it's a rectangle. All right, so super easy, guys. This is going to be only 3 total steps. I'm just going to circle down my givens. All right, so do I have a right angle? Yeah, but I got to talk about it. So at step 2, let's say angle Q is a right angle. And that's because perpendicular lines create right angles. That's it. Now that I know I have a parallelogram, so I didn't have to prove it here. They just gave that to me. I know it's a parallelogram. I know I have a right angle. Therefore, it's got to be a rectangle. So at step 3, I can say PQRS is a rectangle. And that's because if a parallelogram has one right angle, it's a rectangle. And that's it. All right, moving on to our next proof. All right, so I'm giving you a parallelogram, PQRS. Okay, so again, I'm giving that to you, so that's the part you don't have to prove. I won't always give that to you, but that's what's making these proofs a little bit easier today. And I'm also giving you that PSR, so I'm going to highlight him in pink, is congruent to QSR. Prove it's a rectangle. So if we know those triangles are congruent, that means we know all their corresponding sides are congruent. So my first instinct is that we're not going to talk about right angles here because I don't know anything about perpendiculars, but I do know that two sides are congruent as a result of this. And that's namely PR, which is this guy right here, is congruent to QS. Those are the diagonals. So because the diagonals of a parallelogram are congruent here, that would give me a rectangle. Okay, so this is another short little 3-step proof. Just getting our basics down. All right, so I'm going to write down that PR is congruent to QS because corresponding parts of congruent triangles are congruent. Now I can say triangle PRS is congruent to triangle QSR. Oh my goodness, what am I doing? Sorry, I don't know why I just started doing that. I kind of had a moment elapse. That was my given, right? I use that to prove that PR is congruent to QS, and therefore I have a rectangle. My mistake. Okay, and that's because if the diagonals of a parallelogram are congruent, it is a rectangle. All right, moving on to proof number 3. All right, so I'm giving you angle 1 congruent to angle 2. PR is parallel to QS, and PQ is perpendicular to QS. I want to prove that this is a rectangle. Now, this one's different than the ones that we did before because notice I didn't give you that it's a parallelogram. You're going to have to prove that it's a parallelogram first. So you got to think to yourself, okay, why did they give me angles 1 and 2 congruent? And you should be thinking, okay, if those are 1 and 2, that creates this Z shape, which ultimately tells me that these sides will be parallel because alternate interior angles that are congruent would create those parallel lines. Now I know it's a parallelogram because I have both pairs of opposite sides parallel. Angle Q is a right angle, so therefore it's a rectangle. So this will take us 5 steps. So first thing I'll say is PQ is parallel to RS because if alternate interior angles are congruent, lines are parallel. So then at step 3, I can say PQRS is a parallelogram because if both pairs of opposite sides are parallel, the quad is a parallelogram. Now let's talk about the fact that it's a rectangle. So at step 4, I can say angle Q is a right angle, and that's because perpendicular lines create right angles. And now I can say PQRS. Oops, I'm sorry. I just realized I've been writing this wrong. It's PQSR. We switched these letters. PQSR, I'm going to fix that right here, is a rectangle because if a parallelogram has a right angle. It is a rectangle. All right, so hopefully you kept up with that pretty well. So we proved parallelogram, proved the right angle, therefore it's a rectangle. All right, we have one more proof to go through. That'll take us 4 steps. I'm giving you these 2 triangles are congruent. AB is congruent to DC, and AC and DB are congruent. I want to show that ABCD is a rectangle. Now, by having those triangles congruent, I can pull their corresponding sides. So I know AD would be congruent to BC. AC being congruent to DB is giving me the diagonals. Now, keep in mind here again that they're not telling you that this is a parallelogram. You have to prove it's a parallelogram first. So I'm going to prove it's a parallelogram by saying both pairs of opposite sides are congruent. Then from there, I know the diagonals are congruent, so therefore it's got to be a rectangle. All right, so this will be 4 steps. All right, so I'm going to start by saying AD is congruent to BC. I'm pulling that from these corresponding, or these congruent triangles. So those are the corresponding sides. So corresponding parts of congruent triangles are congruent. Okay, so now that I have AD congruent to BC, and they told me the other pair of opposite sides, AB and DC, we're good to go to say that this is a parallelogram. So if both pairs of opposite sides are congruent, the quad is a parallelogram. Okay, now they told me the diagonals are congruent, so now I can say it's a rectangle. So if the diagonals of a parallelogram are congruent, it's a rectangle, and then you're done. Okay, so in summary, guys, if you have a parallelogram, either I've given it to you or you've proved it to be a parallelogram, you got 2 options. You can prove the diagonals are congruent, and that'll justify a rectangle, or you can prove you have 1 right angle, and that'll justify a rectangle. Okay, so that's it. That's how you would prove a rectangle. So tomorrow's lesson is going to go through rhombus, and then I'm sure you can think of where this is going, then we'll start talking about square. So that concludes our notes for the day. The rest of the time, you can work on your homework.